Museum. These robots are anything but small fry. The very first robot we're going to be looking at, which is also the largest on the list, is the RoboBee built by researchers at the Harvard Microrobotics Lab. In development now for over a decade, the tethered version of this microrobot is about the size of a quarter. The RoboBee is made of carbon fiber and weighs just a fraction of a gram. Capable of carrying a tiny camera, researchers see the RoboBee being used to monitor environmental hazards and for use in search and rescue missions. Not too long ago, the RoboBee saw a major upgrade, equipping it with an extra pair of wings, reducing the weight of its power electronics, and integrating high-efficiency solar cells. The RoboBee is now capable of untethered flight. The newer version is called the RoboBee X-Wing, and although it's larger than its predecessor, it still only weighs 259 milligrams. And there's little doubt that the researchers will be able to. Not too long ago, the RoboBee saw a major upgrade, equipping it with an extra pair of wings, reducing the weight of its power electronics, and integrating high-efficiency solar cells. The RoboBee is now capable of untethered flight. The newer version is called the RoboBee X-Wing, and although it's larger than its predecessor, it still only weighs 259 milligrams. And there's little doubt that the researchers will be able to miniaturize it even further. Next on the list, coming out of Georgia Tech, we have the BristleBot. This multi-legged robot is made with a 0.3mm thick actuator block with 4 to 6 legs fabricated by 2-photon polymerization lithography, very similar to SLA 3D printing. The BristleBot weighs only 5 milligrams with dimensions of 2 by 1.87 by 0.8 millimeters and has 4 to 6 legs depending on what it's going to be used for. It can move around by picking up vibrations of external sources like a speaker, ultrasound, or sonar waves, or through oscillations caused by the onboard piezoelectric actuator, and moves at 8 millimeters per second. Piezoelectric actuators convert electrical energy directly into linear motion or the reverse, creating electricity from vibrations, theoretically allowing them to power up a sensor. Changing the size and design of the legs allows them to respond to specific resonant vibrations, and connecting two BristleBots of different sizes together allows the BristleBots to be steered towards the desired direction. The BristleBots are capable of sensing subtle changes in the environment, and working together, they can be used to carry heavier objects. Their stated purpose is to be inserted into the human body for medical purposes. The next robot on the list is another. They can be used to carry heavier objects. Their stated purpose is to be inserted into the human body for medical purposes. The next robot on the list is another millimeter scale robot, aptly called the Milli Robot. Created by researchers at the Max Planck Institute in Germany, this untethered robot is capable of walking, rolling, climbing, jumping, and swimming. Also intended to be used to transport medication, this robot is much more maneuverable, and a single robot is capable of carrying an object. The Milli Robot is made of a 4mm strip of elastic silicone embedded with magnetic microparticles. By using external magnetic fields, the robot can be maneuvered and made to perform the wide variety of tasks it's capable of. The incredible mobility of the Milli Robot makes it ideal for minimally invasive medical applications inside the human body. Researchers hope to use it to transport medication to the specific areas in the body where it is needed, introducing it into the body either by swallowing the Milli Robot or inserting it into the body through a small opening in the skin. From there, it can move through the digestive tract or through the bladder to get to where it needs to be. One goal is to have the robot perform diagnostics opening in the skin. From there, it can move through the digestive tract or through the bladder to get to where it needs to be. One goal is to have the robot perform diagnostics and therapy in areas currently inaccessible without a scalpel. Now, if you're thinking that robots couldn't possibly get any smaller than this, just hold tight because we're not even halfway down the list. The Bubble Jet Microrobot, also created by researchers based in Germany, is smaller than a millimeter, its dimensions being 0.8 by 0.8 by 0.14 millimeters. The robot is made from such flexible materials that it can be bent and deformed without breaking, allowing it to pass through capillaries or other small channels in the body. More development is needed before it can use its propulsion system to navigate through the body, as it currently requires a solution of water and hydrogen peroxide to move. The robot has two rolled polymer tubes that run lengthwise along each side of the body, and a small amount of platinum that coats the inside of the tube causes a catalytic reaction, shooting out dual jets of oxygen bubbles that provide thrust. According to the lead researcher, if no heat is applied to the robot, only one tube will expel oxygen bubbles, making it swim in circles. If some heat is applied, both tubes will expel equal amounts of bubbles and it will swim in a straight line, and if even more heat is applied, it will swim in the other direction. Heat is provided by wireless energy that is picked up by a tiny antenna, similar to wireless inductive charging. The robot also has a thermal-responsive manipulator arm allowing it to grasp and to drop tiny objects by controlling the heat. And if that wasn't enough, it also has a tiny infrared LED on board, allowing the microrobot to be tracked while it travels through the body, the objects by controlling the heat. And if that wasn't enough, the robot also has a thermal-responsive manipulator arm, allowing it to grasp and to drop tiny objects by controlling the heat. And if that wasn't enough, it also has a tiny infrared LED on board, allowing the microrobot to be tracked while it travels through the body. The goal is to have the microrobot provide targeted delivery of medicine, including diagnostic and even surgical procedures. Continuing down the board, allowing the microrobot to be tracked while it travels through the body. The goal is to have the microrobot provide targeted delivery of medicine, including diagnostic and even surgical procedures. Continuing down the list, it's time to break out the microscopes because the next robots are at the micron scale. The next robot is 40 to 70 microns in length, 40 microns wide, and a height of only 5 microns, a micron being 1/1,000,000th of a meter. The Cornell microscopic robot looks like it comes right out of a science fiction movie. For scale, the robot is a little larger than an amoeba, but smaller than a single-celled paramecium. These are the first microscopic robots to incorporate semiconductor components, allowing them to be controlled and made to walk. Each robot consists of a simple circuit made from silicone photovoltaics, which function as a torso and brain, and 4 electrochemical actuators that function as legs. The legs are constructed using atomic layer deposition and lithography, and made of strips of platinum only a few dozen atoms thick, and are capped on one side by a thin layer of inert titanium. The legs are actuated by flashing laser pulses at different photovoltaics, which applies a positive charge to the platinum, causing negatively charged ions to absorb onto the exposed surface from the surrounding solution to neutralize the charge. The ions force the exposed platinum to bend, allowing the robot to walk. So by toggling the laser back and forth between the front and back photovoltaics, the robot moves. The robots operate with a very low voltage of 200 millivolts at a low power of 10 nanowatts. Because they are made with standard lithographic processes, they can be fabricated in parallel where 1 million robots fit on a 4-inch silicone wafer. Researchers hope that swarms of these microscopic robots could be dispatched to probe the human brain, or suturing blood vessels, or even restructuring materials. Given the research is supported by the U.S. Army Research Office, an element of the Combat Capabilities Development Research Laboratory, as well as the U.S. Air Force, supported by the U.S. Army Research Office, an element of the Combat Capabilities Development Research Laboratory, as well as the U.S. Air Force, you'd be forgiven for thinking these robots could be used for more deadly purposes down the line. And now, for some nightmare fuel, here are dozens of these robots being sucked up into a syringe. Now, if that wasn't scary enough, researchers from MIT are developing microscopic robots light enough to float in the air. I won't go into too much detail about these as I didn't find very much material, but their aim is to put microscopic electronic circuits onto tiny colloid particles which are light enough to float suspended in liquid or even air. Their aim is to have the robots carry out diagnostics, from the human digestive system and bloodstream to oil and gas pipelines, and even waft through the air to measure compounds inside a chemical processor or even air. Their aim is to have the robots carry out electronic circuits onto tiny colloid particles which are light enough to float suspended in liquid or even air. Their aim is to have the robots carry out diagnostics, from the human digestive system and bloodstream to oil and gas pipelines, and even waft through the air to measure compounds inside a chemical processor or refinery. These robots are about the size of a human egg cell and don't need any external power sources or even batteries. Their circuits would receive all the power they need from a photodiode. The last robots we're going to look at are created by researchers out of the University of California at San Diego. They're tiny ultrasound-powered nanorobots designed to swim through the bloodstream and remove bacteria and toxins. Using gold nanowires coated with a hybrid of platelet and red blood cell membranes, these nanorobots are capable of performing 2 different tasks simultaneously. The hybrid cell membrane coating allows the nanorobots to function as platelets, which bind pathogens like MRSA bacteria, and to function as red blood cells, which absorb and neutralize the toxins produced by these bacteria. The gold nanowire responds to the ultrasound, giving the robots the ability to swim. At less than 2 microns in length, these are the smallest robots on this list. At the time the article was written in 2018, researchers had yet to try them on live animals, and it's not clear if there were any significant advancements since then. Tests that were done at the time with blood samples showed that 5 minutes after having the nanorobots treat MRSA contaminated blood, the samples had 3 times less bacteria and toxins than the untreated samples. That's going to be it for this video. Some of you may be wondering, hey, what about DNA robots? And yes, they actually do exist, but we'll come back to them in a future video. This wasn't an exhaustive list, so if you feel I missed some important robots, make sure to let me know in the comments and I'll include them in a future video.